Hello friends, welcome to the channel Physics by IITians.
Hello friends, in this video we shall discuss some previous year solved paper from IIT JAM and the topic is electrodynamics. So this video is very much important for you if you are a JAM aspirant or if you are going to give some MSc entrance test for in the physical science subject. So let's start the video. So the first questions has come in JAM 2019 paper. The question is a small spherical ball having charge q and mass m is tied to a thin massless non-conducting string of length L. The other end of the string is fixed to an infinitely extended thin non-conducting sheet with uniform surface charge density sigma. Under equilibrium, the string makes an angle 45 degree with the sheet as shown in the figure. Then sigma is given by option A mg epsilon naught by q, option B root 2 mg epsilon naught by q, option C 2 into mg epsilon naught by q, and option D is mg epsilon naught by q root 2. So what will be the correct option? Look here, the first of all you should understand what the problem tells you. So there is a, this is the infinite sheet, okay, and it has a charge density of sigma, and this mass or spherical ball of mass m, it is making an angle 45 degree with this sigma sheet. Now, first of all, it is has been given that under equilibrium condition. So under equilibrium means the forces that are acting on the ball, it is within the equilibrium, that is equal and opposite amount. Now what are the forces that this ball is experiencing? This ball is experiencing two forces, one due to this gravity and another due to this sigma charge density, that is a electrostatic force. Okay, so whenever these two forces will be equal, the ball within this equilibrium position. Now tan theta is F by mg, where F is the electrostatic force and mg is the gravitational force, and the tan theta is y by x, that is the gradient, that is the angle that is making with the ball with this sheet. This is theta, the angle. So tan theta can be written as F is q into E, as the q charge of the ball is q. So q into E divided by mg, or in terms of q into E, you can write E as sigma by 2 epsilon naught as the electric field for this charge distribution. So you write q into sigma divided by 2 epsilon naught into mg, or sigma can be written as twice mg epsilon naught by q into tan theta. Now what is theta? Theta is 45 degree, that is given. So 2 mg epsilon naught by q into tan 45 degree, that is 2 mg epsilon naught by q. So friends, here the equilibrium condition, that is the key point of this answer. So suppose this is not you are not finding out you are not given the force. Okay, suppose they are telling you that this is not a sheet and this is some kind of other configuration, and then you have to consider that force also. So whenever there are equilibrium condition, you first find out what are the applied force on that object and then make equal them. Okay, the next question, and this is very easy question. Consider the normal incidence of a plane electromagnetic wave with electric field given by E equals to epsilon E naught exponential k1z minus omega t x cap over an interface at z equals to 0. And this separating the two media, one with the wave velocity v1, another with the wave velocity v2, where v2 is greater than v1, and the two wave vectors that are k1 and k2 respectively, and as shown in the figure, the magnetic vector of the reflected wave is how much? First of all, don't worry, this is very easy question. The electric field direction is given as x cap. So E equals to E naught exponential k1z minus omega t x cap. Now the traveling direction is along z, because k, that is the wave vector is along the z direction, that is k1z. Now this is like this way, so it is k1, this is medium 2 with wave vector k2, and this is medium 1 velocity v1, this is medium 2 velocity v2. So the medium 1, the wave is propagating like this way, so after reflection it will go backward like this way, right? So you know that this is they are asking you the magnetic field vector for this reflected wave will be what. Now look at this, the wave vector electric field vector along x and the wave vector along this direction along z. So x and this is z. So we know that E and B and Z, K, all are mutually perpendicular for the electromagnetic wave. So this is the wave vector for the this is the electric vector for this wave, and this is the wave vector for this wave. So B will be E cross B, okay, or K should be E cross B. So E cross B direction will give you the K direction. Now if E is along X cap, so B will be along Y cap, so that the K vector will be along Z cap, okay. Now the K vector will be reverse, that is K vector will be along negative z, because this is the reflection, so reflecting. So the medium, it will, this boundary will act as a reflector, so the traveling direction of the wave will be reversed, and it is along the negative direction, negative z. So E cross B this time should give you the negative z direction, and it will be minus E naught by V1 exponential iota minus k1z, because the wave vector will be reversed, minus k1z minus omega t. So this is the correct answer. So you have to understand that what these two terms represent. That these two terms, one is the propagation direction, this is the phase term, that is k1z minus omega t, and this is the plane wave, because this phase will be constant throughout its propagation. So k1z is the positive direction, propagation direction along positive z, and so minus k1z is the propagation direction along the negative z, okay. Let's come to the next question. During the charging of a capacitor C in the RC circuit, the typical variation in the magnitude of the charge Q of T deposited on one of the capacitor plates and the current I of T in the circuit respectively are best represented by figure 1 and 2, figure 1 and 4, figure 3 and 2, figure 3 and 4. So for the capacitor charging, this is the figure, charge versus time, and for the discharging, this is the figure. So figure A, that is figure 1 and 2, option A is the correct option, okay. The next question, which one of the following is an impossible magnetic field? Now the magnetic field, to be impossible, we should check the condition, that is del dot B should not equals to 0. Means del dot B equals to 0, that is the valid condition for the possible magnetic field. Now check whether del dot B is 0 or not. So for these three options, del dot B is 0. Option D, del dot B is not 0. So option D is the correct option. If they are asking you whether these are impossible electrostatic field or not, then you have to check curl of E is 0 or not. If curl of E is non-zero, then it will be an impossible electrostatic field, okay, because curl of E is 0 will give you the electrostatic field, and if curl of E is non-zero, it will give electrodynamic field, not static. Next question, out of the following statement, choose the correct option or options about a perfect conductor. So the conductor has an equipotential surface. The option B, net charge, if any, resides only on the surface of the conductor. Option C, electric field cannot exist inside the conductor. Option D, just outside the conductor, the electric field is always perpendicular to its surface. Now friends, I have briefly discussed these concepts in previous videos, and the link will be given in the description box, or you can get it pressing the I icon in the video on the right side of the video. So all the four options are correct. The conductor has equipotential surface, it is true, and the net charge, if there is any net charge, it should always reside on the surface of the conductor, and the electric field inside the conductor is 0. and just outside the conductor the electric field is always perpendicular to the surface. So friends, you can join our test series for your JAM preparation, and the first test on 1st December 2020 will going to happen. So do hurry, join here. For the minimum cost for the full length test series, you will get 5 different tests with only rupees 250, and you can contact us in our mail, that is da834@gmail.com, or in our telegram channel Physics by IITians, or contact us to this number. So or you can also join for the interview guidance program with a minimum cost, that is 699 rupees per for 1 year, and also those already have joined our test series, they can get the interview guidance with minimum cost of 500 rupees for 1 year. So thank you for watching this video. Please do like the channel, subscribe to our channel, and also share our videos to your friends, and join our telegram channel for daily quiz updates and research updates. Thank you.